Evaluate the limit at x equal to pi over 2 from the left-hand side of the difference secant of x minus tangent of x. We first check the limit of each term. The limit at x equal to pi over 2 from the left-hand side of secant of x is the limit at x equal to pi over 2 of 1 over cosine of x. And at x equal to pi over 2 from the left-hand side, cosine of x equal to 0. But this is not quite 0. This is a very small number. So this limit is positive infinity. Similarly, we check the limit at x equal to pi over 2 from the left-hand side of tangent of x. And from the graph of tangent of x, we see that this is also positive infinity. So this is the limit of the indeterminate form, infinity minus infinity. We will need to rewrite it as a ratio if we are to use the L'Hopital rule. Rewrite it. This is the limit at x equal to pi over 2 from the left-hand side. With any trigonometric function, it is better to rewrite everything in terms of sine and cosine. Secant of x is 1 over cosine of x, and tangent of x is sine of x over cosine of x. And we see that the two terms have the same denominator, so that we can combine the rational expression. The common denominator is cosine of x. The numerator is 1 minus sine of x. And we checked the condition of the L'Hopital rules again. If we were to take the limit at x equal to pi over 2 of the numerator alone, sine of pi over 2 is 1. 1 minus 1 is 0. Cosine of pi over 2 is 0. Both of these, the numerator and the denominators, are continuous functions. So to find the limit, we simply plugged in the values. This is the indeterminate form 0 over 0. So we can use the L'Hopital rule. Using the L'Hopital rule, we would differentiate the numerator and the denominator separately. The derivative of the numerator is 0 minus cosine of x, and the derivative of the denominator is negative sine of x. Treat this as a new limit. The limit at x equal to pi over 2 on the left-hand side of negative cosine over negative sine is simplified to cosine of x over sine of x. Now, the numerator and the denominators each is a continuous and differential function, and to find the limit of continuous function, we check that at x equal to pi over 2 from the left-hand side, cosine of pi over 2 goes to 0, and in the denominator at x equal to pi over 2, sine of x goes to 1, and 0 over 1 is 0. And again, as x goes to pi over 2 from the left-hand side, cosine of x goes to 0. We're not saying that cosine of x equals 0, but this is the limiting value. Similarly, at x goes to pi over 2 from the left-hand side, sine of x goes to 1. This is the limiting value. It is not that we say sine of pi over 2 is 1, because it is possible that x never get to pi over 2. It is approaching pi over 2 from the left-hand side. Regardless, 0 over 1 is 0, so this limit is 0.